So welcome back. This is the third and final session on transnational access. We've seen throughout, actually, that although we've tried to divide this up into sections on distinct challenges, it's all interconnected. So nominally, the themes today, and you'll note we have a very large panel because it started off with two themes that have been brought together, are first of all the challenges in approaching really broad global challenges which may require bringing together measurements, groups from right across the world to solve these increasingly complex problems. We saw this with the response to the global pandemic. We see this with responses, for example, to ecological challenges, where, of course, the entire planet is the system that we're studying, and we have at least two speakers, if we can find one of them, who are going to be talking about that challenge. And, of course, there's a whole area that has become known as multimessenger measurements, bringing together, again, measurements from across physical, usually physical types of measurements to solve increasingly challenging problems. We also have a theme to do with the use of RIs as fora or hubs to bring people, to bring scientists together, to generate new ideas, yes, but also as places where knowledge is created, where skills are developed, where we also engender, we discuss issues around equity. And Matthew Wright, in the opening session, framed it in a beautiful way from the GSO perspective, saying equity is also one of the things we're trying to improve and develop here. So, as I've said, the various themes concerning transnational access are closely interconnected. It's difficult to separate them. We have 9 speakers who are going to address aspects of these challenges from different perspectives. We're going to break up the session, so the first 5 speakers, it'll be the same format as the previous sessions if you've been to them, will each come and give their presentation, and then we have the opportunity to put a number of questions to them. We have some that have already been submitted, but please use the app to submit your additional questions, and they'll come through and we'll pose them to you at each question stage. And if the app fails or for whatever reason you can't use it, then the traditional message of sticking your hand up will also work. So the first 5 will speak and we'll have the questions, and then we'll have the second 4. And I think what we can also do right at the end is ask for some perhaps concluding reflections or remarks, what the various contributors would like to add in reflecting on the things that have been discussed in that section. So without further ado, I should say, incidentally, if you weren't in the first session, my name's Andrew Harris, and I run a national infrastructure, but I've also been an ESFRI delegate in the days when the UK was allowed to be ESFRI delegates. And I'm about to move to a research infrastructure in Prague in about a week's time. So pleasure to see so many of you back. And I think without further ado, I'd like to invite Apostolia Karamali, who's from DG R&I and is one of the people who's leading initiatives into foster global collaboration across research infrastructures. So Leah, please, the floor is yours.
Thank you, Andrew. Good afternoon, everybody. A pleasure to be here with you. So I will be sharing with you some initial thoughts to put from a public policy perspective how we propose to underpin global collaboration for science. And of course, the other speakers will come with concrete examples, and hopefully then, as Andrew explained, we can see how all this fits in the big picture. So this is an introduction on my end on how the EU approaches global cooperation when it comes to research and innovation. And actually, the discussions, this is not new. However, we have recently had quite intensive discussions from a policy perspective with Commission proposals and with a strong commitment of the Council and many stakeholders about how we can improve and what should be the renewed objectives in this global cooperation for research and innovation. So already in 21 last year, there was a communication from the Commission, and this then triggered conclusions from the Competitiveness Council of the European Union, and we're now into a renewed implementation phase with international partners. So this is the global context, and what has been the rationale for this renewed approach? First of all, which are the drivers for this global cooperation in science? From a policy point of view, we need to find solutions to global challenges. In particular, the twin transitions, the digital and green transitions, but of course, with continued commitment to sustainable development goals. But we also want to promote Europe's resilience, prosperity, and competitiveness. At the same time, what is probably new in the debate is also the need and the driver to have a reciprocal openness, while we underpin a free exchange of ideas and co-creation of solutions. So yes, we admit science needs global cooperation. At the same time, while joining forces, it is also important that we join forces in a reciprocal way. And this takes into account the global policy context. Secondly, what has been the approach in this renewed approach to international cooperation? As I was saying before, the main objectives, which you can see on the left-hand side, are, of course, to preserve the openness, which is fundamental for science, while at the same time promoting a level playing field, and in addition to that, make sure that we have the right bilateral and multilateral partnerships that are necessary in order to be able to bring to the fore these solutions to the global challenges. And how will this be achieved? The European Union has a long tradition of bilateral cooperation with numerous scientific and technical agreements, I dare say almost with a very great number of countries across the globe, and this is of course renewed. And so therefore the bilateral cooperation is fundamental, and so is multilateral cooperation, and we use all possible fora, formal and less formal, in order to promote this. And finally, what is also quite important is this new Team Europe approach, which is promoted in different contexts, also for international cooperation, where Europe comes with all its diversity and all the different levels, so both the member state level, the European Union level, but also stakeholders, in order to bring the solutions that are necessary. Another important characteristic of this renewed global approach for research and innovation is the focus on science diplomacy. Again, this is not new. There have been science diplomacy has been used on several occasions, and there have been different definitions. For example, science to underpin diplomacy, but also diplomacy to promote science, important science objectives. And we saw that, for example, in the recent pandemic, but also in other areas. What the intention is from the political side is also to promote and to come up with a science diplomacy agenda, some sort of an action plan, allow me the term, which is due for next year to be discussed and agreed at ministerial level. And of course, this is underpinned by the rich portfolio of the different agreements that I mentioned before. Maybe a last point on my side: which are the values and principles that should drive this global cooperation for science? In the last 2 years, there has been a quite strong and animated debate on values for research and innovation more globally within Europe, but also for global cooperation. And what you can see here is the outcome of this discussion when it comes to values and principles that should underpin the global cooperation seen from the EU perspective through this Team Europe approach that I mentioned before. As you can see, first on the list from the left-hand side is freedom of scientific research. This is an extremely important element. For this, we have had several declarations addressing both education and also research aspects, and there is a continued engagement and commitment to promote the freedom of scientific research and to see how concretely this can be monitored and underpinned within Europe, but also internationally. The second principle that you can see here is ethics and research integrity. And this is quite much linked to the first objective, and it addresses several aspects that can range from how can we capture any possible risks to freedom of scientific research, and what can be done in order to make sure that we mitigate those risks. And for this we have several bilateral discussions, but we also use multilateral fora, such as in the G7 context. Then other values and principles, of course, I go without being very long: research excellence, inclusiveness, and gender equality, open science, a lot has been said in this conference, ethics, for example, in artificial intelligence, but also continuing to the right, intellectual and industrial property rights, value creation, societal environmental responsibility, solidarity, and finally risk management and security. So I think what is new is that for the first time we have a list, a concrete list, and on this basis we have a series of multilateral dialogues involving several actors from the European side and countries from the international side that want to engage in this. And here you can find more information about these elements that I have been presenting to you, and I'm happy to continue to the discussion later on. Thank you.
Leah, thanks for getting us off to such a great start. I'm sure we'll prompt questions, and we'll come back to that later. So next off, we have Giorgio Rossi, former chair of ESRI, played a leading role in setting technology infrastructures, but here is going to give a GSO perspective, I believe, having served for many years on GSO. I hope that's the case.
I was asked to dwell on complex. It has to do something with GSO as well.
Okay.
And complex science. And I like to take this example. It's familiar to most of you. This is the important measurement of gravitational waves 5 years ago, because it introduced a new method and a new perspective and a new dimension of international collaboration. Now, what are complex scientific questions? Complex scientific questions may arise with events. We had, of course, the COVID, we have the climate change. These are real complex things, but they may, in science, arise also from theory. Theory is a combination of reasoning and computing, and we are happy with the theory when it does explain some natural facts, and we are even happier when we can go and test the theory to its limits. And so Einstein made 100 years ago his general gravitation theory, which includes something fascinating, and that's the fact that the time-space in which we all live is vibrating. There are very tiny vibrations that keep it together, and the galaxies and the planets dancing the way they do. But these tiny vibrations are tiny, and so even himself thought that there might be hard to detect. And if you don't detect, you don't prove the theory. So there was a big effort, and the big effort was finally successful after several technology generations for the detectors. The current one is based on large interferometers. And suddenly, in 2017, an important event happened. And this event was detected by those two red things in the United States and by the lower red symbol in Europe. And they measured gravitational waves. So it was the first clear detection. Now, why it's so important? First, because we are using the globe. We need to have a distance between the detectors to make not just a detection, but to try to understand where it's coming from. So to have a telescope, to aim at a particular sector of the sky. The Earth is small, so we have to use it all to have it. It's already an element of for collaboration. Then what was observed is this thing. The two advanced LIGO detector interferometers in the United States and the advanced Virgo in Italy identified and localized the coalescence of 2 neutron stars. Great, it was evidence. Now, this evidence was strong because the 3 detectors had a signal and the statistics of these signals were combined. So exchanging data in a competition for science that it needs to be collaboration at the same time, you exchange the data, you validate the data, and you are sure that it's a discovery. This is the first point. Then, within a very short amount of time, 2 seconds of our time, after the gravitation was detected, the sky telescopes were aimed towards the same direction where the gravitational signal came from, and they could detect the gamma ray burst that is also expected to accompany such a collapse of neutron stars. And then within a short time, more than 2 seconds, but still very useful to complete the observation, over 70 ground telescopes, those that were on the good side of the Earth at that time, were aimed in that sector of the sky, and they could measure through the whole electromagnetic spectrum, so from infrared to X-rays, the products of the signals from the kilonova that was generated by the collapse. So why I'm mentioning this? Because it's a good example of the fact that you need to cross-validate from several observations. So you need to compete, collaborate to have a discovery on a difficult issue. The reproducibility of the data, it's again from the same thing. You observe similar, and then you're sure you have observed. If you go alone, you might suspect of an artifact. You can analyze these data, making them as open as possible, at least through the community interested in gravitational waves. Then huge computing, reasoning, analysis work is done, and we reach some new knowledge. Now, the message is that all complex research, so when addressing complex issues, needs a multi-messenger approach, as it was called in this case, using research infrastructures in the different domains, and this can work if the research infrastructure are to a good degree interoperable among themselves and anyhow produce data that are interoperable so that some scientists can address a complex problem knowing that he can find data that were professionally obtained by the best experts of that particular domain, and maybe combining reasoning, computing can help in reaching new knowledge that will hardly be doable on very complex issues working alone. And that's the message from this.
Giorgio, thanks again. Dangerously close to a science lecture, and I'm sure it'll prompt questions as well, so no, thank you very much. So next up we have Paco Colomao, who again has several hats, one of which is current ERIC Forum Chair, but I think in this context you're going to be telling us about some of the activities of Jive ERIC, which brings together 20 radio telescopes globally. So Paco.
Thank you, Andrew, and thank you for the opportunity to talk today. Half of my talk has been given by Giorgio, okay? So I'm going to be very short. So but the point I think I wanted to stress is indeed the importance of the international collaboration and the opportunity of the collaboration for diplomacy, as Leah said, in both ways. Diplomacy for collaboration, collaboration for diplomacy. And for this, I'm going to use this, which is this one. We use this. So this is a network of radio telescopes called the European Bmbi network, which, as you see, is not only European, because it has telescopes that are located in all continents, okay, all around the world. The infrastructure, the EVN, which is coordinated by Jive ERIC in the Netherlands, This was started in 1984. Okay? So it's not precisely an occurrence. It's really the need that existed at that time and the technical possibility of combining signals of different telescopes to create a new instrument. That it is a virtual telescope, a new instrument that is, has the resolution power, the capacity of one virtual telescope as big as all the whole of the Earth. So when we look at the objects, as George was saying, if you want to locate or see the details of an object, you are limited by your instrument, by the size of your instrument, among other things. And in this, with this technique called Bmbi, you change the concept of size of your telescope to distance between telescopes. But you have to observe with all the telescopes at the same time the same object, send the data, and analyze that data. This is what we do at JIVE. We observe with all this network for one single team of astronomers that have one specific science project. Okay, so doing this is not precisely easy. The challenge is not only technical. The challenge is also political. It's also financial. It's also, I mean, each one of these telescopes are national facilities. They have their own strategy, their own ownership, their own finances, but they decide to get together, and even they decide to create an institute together, that is JIVE, and in that sense they give an extremely added value to their national facilities. Well, everybody has seen this, I think. Half of the population of the Earth has seen the shadow of the black hole in M87, okay? This is what one expects to have in the center of this galaxy, far away. This is supposed to be an animation. Maybe if I click, it will start. Yeah, okay. And then, this is what we knew, okay? This actually was, it received the Nobel Prize. It was the study of the movement of stars in the center of a galaxy that said, well, there is something there, and there is a big gravity generator there, but we don't see it, okay? Now, when the Event Horizon Telescope, which is a Bmbi instrument, just like the one I showed you, was ready to take this image, well, just to make you the comparison, it is equivalent, the angular size, to one of the 1,000 eyes of a fly that is located 10 kilometers from you, okay? So we are looking at the sky to that kind of very little details of the celestial objects. But now, well, this is not but the start of my story, because what I actually want to show you is this. This black hole is in the middle of the galaxy M87, which is enormous. It's one of the biggest. And the whole of its structure needs to be explained by a jet of material that you can only see coming from the center black hole with a combination of techniques. So you have the EHT down there looking at the black hole, but then you have, and I'm sorry, maybe the quality is not too good, but you see different instruments, some of them Bmbi instruments, including the EVN, which is up there, but also optical instruments, and you have to combine all this information, just as Giorgio was doing with, you have to combine all of this to get the whole picture. Otherwise, you will not really understand what is happening in this. And this means a lot of teams working together, developing complementary instrumentation and complementary science. So, because I only have 2 minutes, I think, this doesn't end here, okay? Because actually what we are getting together is similar infrastructures, the European one, but also the one in East Asia, the one in the United States, and the one in Australia. We are getting them together to talk together to create an alliance. It was called the Global Bmbi Alliance, and this is in order to respond to new challenges. And one of the new challenges is how to combine these techniques with new instruments that are coming, and in particular with the Square Kilometre Array. Everybody has heard here about the Square Kilometre Array, okay? This huge instrument that is being built, half of it in Africa, South Africa, and then the rest of Africa, the other half in the western deserts in Australia. the square kilometer array, when it is built in the first phase, it is mostly located in the south of Africa and in some part of Australia. What we are doing here is we are combining this instrument with the Bmbi networks that exist to precisely bring the baselines, the mid distances that are not included in the original instrument. And what that is also helping us, the community, not only Jive, is to help also the development of Bmbi in Africa, which is something that we have heard today in several of the panels, and it is actually not only an element of diplomacy, it's also an element of capacity, human capacity building. So all of that, it is strongly supported by all this multi-messenger work by several of the programs, in particular in the European Commission Horizon 2020, now in Horizon Europe. And there are a couple of projects here. ESCAPE, the European Science Cluster of Astronomy and Particle Physics, that actually has the last meeting next week. It's going to be interesting, because there's still a lot to do, but the project is ending. And then the new, well, now one-year-old optical radionet pilot project, which also tries to get together the radio facilities with the optical facilities in order to, well, do a lot of new developments also in strategies, access, funding models, etc. So thank you for now, and I look forward to continue later with the questions.
Paco, thank you very much. Really nice compliment to Giorgio's talk. So we're now going to come down to earth and talk about facilities which are around analytical research infrastructures. And Miriam van Dalen is going to talk about a new initiative, ICRI, which brings together clusters of research infrastructures to get them to work together better. So Miriam, please.
Thank you, Andrew. Okay, thank you. So I would like to speak today about ICRI. It's an initiative of 7 big research infrastructure networks that teamed up in 2020 to work together and to tackle the societal challenges and the missions of Horizon Europe. So this was the idea. So we wrote 2 position papers during the pandemic, and one was on how to complementary work together with these 7 different networks. So what you can see here on the slide, so we have photon facilities, we have neutron facilities, we have ion beam facilities, we have high magnetic field, we have proton beams, and we have lasers. So it's a huge network of networks. And so to support the growing research community across Europe and to bridge scientific disciplines in academia and industry. And it's also a paradigm for global collaboration in large and high-tech projects. The 2 position papers that were written, so one on the Horizon Europe missions, and the other one as a reaction to the pandemic on viral and microbial threats. You can download on Zenodo their open access, and you can read all the details there. So ICRI is a European asset, and I was discussing with Ed Mitchell before that it's basically a gold mine in Europe. All these big facilities, as you see on the map here. Oops, too quick. Yeah. It's more than 120 facilities that teamed up here to work together and to offer complementary services to users. So we are serving more than 40,000 users with all these facilities, and the complementarity of the characterization capabilities of these research infrastructures, they provide a unique vision into materials and living matter. And we were very, okay, now we're going back here, sorry. Yeah, okay, so we were successful in having our first project called Remade for Analytical Research Infrastructures in Europe, which is a hub for materials research, focusing on circular economy, and the project started on the 1st of September this year, and here there is part of ARIA research infrastructures teamed up, so it's more than 50 of the research infrastructures that offer their services suiting any research focusing on the development of new materials for the circular economy. And the added value of this project is that there is a special scientific support by senior scientists and facility experts that really offer a very high user service and help the users to use these facilities and to also use different facilities to tackle one scientific problem. And this also provides special formats to support researchers from industry and also from SMEs. And this is also something that was not was done before in the Calypso project, but here now it's the first time for ARIA that we have this service for different type of research infrastructures. And then there will also be a comprehensive catalog, service catalog and training program to use these facilities. Then I already come to my summary. So how I think we can strengthen this more inclusive access to these ARIA facilities. I think we have to start to think about transnational access in a different way, and that we really, what we did with ARIA already and have in place is to really enhance services for the users and to help them to exploit the research infrastructure's complementarities and to basically give one-to-one user services. And of course also provide TNA for countries that do not operate their own research infrastructures. Then I think networking activities are still very important, to work together, to team up, and to not do things on your own, but together. And then joint research activities have always been very important in the past to, for example, develop data analysis service and also services on technology development with projects that we had before. And I think projects like Remade at ARI is another example. I think these are very good projects to give this add-on in better user services for the users of our facilities. And then again, of course, we come to this data infrastructure, which is, we heard already very often the last 2 days, to handle the data avalanche that comes from the experiments at our facilities. And what we really need is semi-real-time on-site data reduction to not create too many data, and data analysis and being able to process the data and to store the data. And of course there are many projects that are already in place, but we are still not there. And then I think that projects like the AELS clusters that are now coming to an end, like the project that you just mentioned before, the ESCAPE. So in the photon and neutron community, there is the equivalent PANOSC and EXPANS, and I think these projects really help to federate data services and to serve the fair data principles, and they lay the basis for data commons. And as soon as we have data commons and we can do data mining, then also the results of our research facilities and the research that our users do, but also that is done at the facilities themselves, becomes much more visible. And I think this is extremely important. And with that, I'm coming to the end.
Thank you very much, Miriam. So before we move on to the last speaker in this section, just a plea for questions. Unless I'm reading this wrong, there have been no questions put in the chat so far, and you'll be reduced to my generic questions to kick things off. Hands in the air work. So I'll just actually, am I right in thinking there are no questions? Yeah, there are no questions. Okay, please, questions. Anyway, last speaker in this section is Anita Hayward from Europlanets, who's going to talk about an initiative to develop collaboration in planetary science. It's a Horizon-funded initiative, but looking at global collaboration in this broad field. Anita, please.
Yes, thank you. So I am going to talk through, I'm going to talk through just briefly 4 case studies, examples of supporting global collaboration through planetary science. I'm going to absolutely whip through these, but there are some QR codes, take you to our website if you want to know a bit more about these. My first case study is the story of a researcher, Barbara Cavalazzi. She's a planetary geologist, and she's interested in looking at life under extreme environments. So geology, the emergence of life on Earth, astrobiology, where we might be able to find life elsewhere in our solar system and on other planets. Her involvement in Europlanet has come about over time. So she visited, using a TA visit in 2010, Morocco. She then proposed a site for characterization in 2015, and she now leads our field analog site access in the current funded project. Barbara has been really instrumental in global collaboration through access for Europlanet. And her network of contacts and her knowledge of extreme environments on Earth have been instrumental in augmenting the offering of planetary field sites by Europlanet around the world, which now span Africa, Asia, South America, and China. And Barbara also leads our global collaboration task and strategy. So she runs a workshop series, bringing together people involved already in planetary science, people who are interested in planetary science, but also working with local communities around field sites, taking people out to the village, from the village out to the field site, running teacher training sessions, working with local schools. And the global collaboration has already led to 2 new EU-funded projects, one for mobility of researchers in Africa and one for early careers training. My second case study is Atomki, which is the Hungarian Centre for Atomic Research. Again, this has come about, the initial interaction with Europlanet came back through a personal connection. Bella Sulik, who was in touch with Nigel Mason, our coordinator who's here in the room, for about 15 years. When Atomki installed a new Tantatron accelerator, Nigel and colleagues from Europlanet went and visited, and the idea was born that they would build a new beamline for astrophysics, astrochemistry. Now, this is useful for looking at how ices in the solar system are affected by the solar wind and by galactic cosmic rays. And this is an opportunity, this is a really good demonstration of how expertise and equipment has been shared through the European community. Europlanet researchers, right from senior researchers down to students, came to Debrecen, trained and shared expertise with the team there. The chamber was installed in 2019 and was ready for the first TA visits in 2020, which were initially virtual due to the pandemic, but has since then been physical, and it's now our most oversubscribed facility within the Europlanet network. And a second chamber from Queen's University Belfast has now been installed through a joint research activity, and that's now also part of our TA programme. The group in Debrecen has increased. There's now an active group of 6 Hungarians collaborating with 3 UK and an Indian researcher, again at all career levels. And Bella gave this wonderful quote, which says that as he's near retirement, when I leave this field, I feel that in Atomki we have something which is really on a European scale, an active laboratory becoming a hub in this field of astrophysics and astrochemistry. My third case study is the Korean Basic Science Institute. This is a government-funded body to support research and development in Korea. Within that sits the National Research Facilities and Equipment, NEFC, which supports the development of research infrastructures in Korea. So it's a bit like, I guess, a bit like ESFRI. But since 2020, KBSI has been collaborating with Europlanet to implement a reciprocal access arrangement. So European researchers can access 13 KBSI facilities, and Korean researchers can access 24 of Europlanet's laboratories, and most importantly for them, the field sites. And this has really had wider mutual benefits on both sides. So KBSI has widened its user community, gained experience of operating an international platform for knowledge exchange and collaboration. During the pandemic, European and Korean researchers worked on finding ways for virtual access. And this has been a successful pilot for co-funded reciprocal TA programs. And my final case study is looking at the wider community, so particularly looking at the Venus community. A few years ago, there was a bit of a sense, why bother with Venus, we know everything about it. And it was somewhat neglected in terms of missions. There were 2 in 30 years compared to, I think, about 22 attempted for Mars. But stimulated by the exoplanet community, looking at the characterization of atmospheres and planets orbiting other stars, there's been revived interest, and actually in the past year, 3 have been selected, three missions have been selected with the target of Venus from ICRI and NASA. And one of the things that helped this, revive this interest in Venus is Venus Express was designed as an atmospheric mission, but a team at DLR proposed that its very small spectral window at 1 micrometer could be used for surface measurements. And through Venus Express, they proved that concept, but it was difficult because there was no spectral library available to help interpret the data. So with funding from Horizon 2020, the previous Europlanet program, we built a new Venus chamber at DLR, and this has helped provide the experimental evidence that you can learn about Venus' surface from orbit. And at the moment, there are 2 teams of researchers visiting DLR this week through Europlanet TA program, and another visit coming up in November. And this has really showed that this DLR chamber is becoming a hub for collaboration and networking between these 3 international meetings, and also the Japanese mission Akatsuki as well. So that is it from me. So thank you very much.
Anita, thank you very much for rounding that off so nicely. So I'd like to invite all 5 speakers up to the front, please. We have a couple of questions. I still encourage you to submit questions, but again, if you feel more happy sticking your hand up, I'll take questions in the traditional way. So there's no particular seating plan. Paco and Giorgio, wherever you can. Thank you. So, I mean, clearly what we saw here was an extremely diverse range of challenges, or in the case of Leah, sort of an overall position on policy. I'd like to just start with a fairly general question and end again with Leah on this one. So looking at your respective challenges, the bringing together research infrastructures that you described, how in the future do you think one could develop the framework within which collaboration is developed to enable more effective engagement between research infrastructures? Who would like to lead on that? Giorgio, was that a nod?
Thank you. As you use the word framework, it solicitates me to speak of an exercise that has been going on for a number of years, that was started by G8 plus 5 international configuration to define the scope and the opportunity for global research infrastructures. Global research infrastructure are meant global efforts in which it's really worth that full international collaboration occurs to reach sooner and better new knowledge for everybody's benefit, from basic science to management of the Earth and of the population that is being redistributed on the globe as it grows in numbers. This science diplomacy, you may call it, but in fact it's an effort to identify things, a common ground, and has been formulated in terms of a framework, of which I can say one important result that was agreed by this large international group, including India, China, was including Russia, of course, at that time, is that the concept of using the research infrastructure must be open access based uniquely on the merit of the proposals. And this has become common understanding and common knowledge through the whole globe, which I think it's a strong basis for collaboration among research infrastructures.
Thank you, Giorgio. Leo, you look like you want to intervene. Thank you.
Yes, so just to build on Giorgio's point on the collaboration in the context of GSO, and taking your question, Andrew, with a little bit of a broader perspective, we can distinguish various levels for these framework conditions, and then hinted a little bit from a policy perspective in my presentation earlier on. So first of all, we need to have the right policy conditions in place, and for this we use the various policy arrangements that we have, multilateral or bilateral and so on, and at various levels, member state level, stakeholder level, or EU level. And certainly the G7 is currently a very an accepted route, and we have been working as Giorgio just explained. At the same time, at the occasion of this conference, and under the presidency of the Czech Republic, the presidency of the EU, the Council has proposed the Brno Declaration, which actually opens up even further and invites for to even step up this international cooperation, even so using all the learnings from the GSO, but also the process that we have through this International Conference for Research Infrastructures, to actually use it as a not only as a conference but as a mechanism to pursue cooperation in the future. So these are, let's say, this would be the policy level. Then definitely another level that certainly facilitates is the level of planning. And this morning we had the early session at 7:30 in the morning, where we exchanged information about the different methodologies that we have from the different geopolitical regions to actually plan ahead for research infrastructures and create the roadmaps. And it was interesting to see similarities and complementarities and even differences in this kind of methodology. But certainly in this kind of field, planning ahead and knowing what is coming up certainly facilitates cooperation. Then we have all the technical elements that popped up in the discussion regarding these framework conditions about interoperability, open access, and so on, that need to be in place in order to be able to exchange data, collaborate. And of course, there we have to add that there are cross-cutting, but also domain-specific aspects. And the final point that I wanted to say is that having all these conditions in place and the right reciprocity that is necessary, funding can come as a facilitator. And certainly from the Horizon perspective, we have always had an openness to international cooperation, but which could be strengthened in the future by having planning ahead certain projects that are necessary in order to pursue these scientific challenges. And we heard some examples today.
Thank you very much, Leah. Any other comments, points from the panel on framework? No. So next is to ask, and this is a question to each of you, in the area in which you presented, what do you think are the key barriers to access that enables international cooperation that still remain? If you had a number one priority of a barrier to try and break down, what would it be, and what kind of action might you propose? Paco. Actually, I better keep this.
Yeah, why not? Yes, the key barriers. I think we are talking about international cooperation and the role it may have and the tool that we have in diplomacy. Diplomacy is complex these days, right? I mean, we have seen this network of radio telescopes, 22 radio telescopes minus 3 in Russia. Okay, we have lost 3 telescopes recently that are not part of the network anymore. But we have had Russia and China and the United States and Europe and all this working together for decades. even in the worst of the Cold War, even in the worst moments, science has always been a tool that we had to keep the collaboration. And it has to continue that way. I know it is very challenging, right? I know, I mean, there are moments in which you just can't do it, but we have to find as much as possible the route for this. Now, the other thing that has been mentioned, challenge, a barrier, how you said?
Reciprocity.
Reciprocity. Thank you. Reciprocity. You don't know the advantage you have the native speakers. Anyway, so reciprocity. Yes. Well, yes, of course. I mean, especially when there is a development that is offered open skies. We want data to be accessible. But not everybody is in the same situation. So reciprocity is okay, but when we are working together with developing countries or with different cultures, we also have to put ourselves in that skin. And we have to realize that reciprocity will come only when we are at the same level. And that may take some time. And I think it is a discussion that it is very important to have, that the most developed countries are not, let's say, having an attitude that is not proper, because at the end of the day we are all together in the challenge, and we are all necessary for the solutions. I hope I have explained myself. Sorry, yeah. It's been a long day.
Very clear. Thank you, Paco. Anita, key barrier in your area?
Yeah, I mean, I think Europlanet is a good example of a distributed research infrastructure where we have a big variety of organisations that are involved in the project, ranging from quite large to quite small, in many different countries, many different cultures, some in quite remote areas, some without much infrastructure behind them. And I think the most important thing for us is making sure that there is dialogue and there is time to make sure that when bringing new research new facilities into the research infrastructure, that we really understand what they want to get out of it and what their long-term objective is, so that we're not just going in there for 3-4 years doing a bit of science and leaving again, that there is a community that develops there sustainably. And also that that we make sure that that there is a good understanding from the facilities point of view about what's required from the Commission in terms of reporting, because it's onerous when for small organisations that don't have that sort of big civil service behind them. It's quite alien, some of the things that are asked, and it can be quite a challenge. So I think sort of time, dialogue, and simplifying as much as possible what's required from the facilities to make sure that it is possible for smaller organisations to join.
Thank you, Anita. Giorgio.
Well, we like to talk about science diplomacy, but we should think that this was the origin, an important element during the Cold War. We were facing in the 60s and 70s a substantial fear for a nuclear war, and the scientists joined together in some important declarations. One was the ICRI declaration, and there were scientists from the two parts of the world that were afraid of making a big mistake, one against the other, right? Then, more recently, we speak of science diplomacy with the reference of a peaceful world, which was true until 2 or 3 years ago. Not completely peaceful, but at least for our comfortable countries. But I'm afraid that we are, again, unfortunately, in a situation in which a potential nuclear conflict may break out, and I think the scientific community should get a little bit back to the spirit of saying, look, it's nonsense. We, the scientists, understand that it's nonsense, and independently of the correct political struggle and all the analysis, we, the scientists, believe it's a nonsense and we understand each other.
Thank you, Giorgio. Miriam, key barriers for you.
Yeah, so I said it already in the summary of my my presentation. I think it's very important to lower barriers for access to research infrastructures and to enable scientists that do not have a research infrastructure in their country and also do not have the experience of a user community to help them with better user services and to really explain also to industry users what our facilities can do and how they can make use of it.
Thank you. And Leah, from your perspective, what do you, looking out at the research infrastructures, what do you see as the key barriers, key barrier, if you like, you can pick any number, and your thoughts about how best to develop policy or whatever it is to overcome them?
Yeah, I think I can dwell on the comments also of the other speakers as well, because here we see a good summary of various points, various barriers that the scientific community addresses at different levels, ranging from solidarity and inclusiveness, simplification, up to going for diplomacy through science, as suggested by Georgia, very important political positioning, I think. So here, indeed, we have a range of different levels of barriers, and I think this is a good, let's say, a good input when it comes to policymakers within Europe, but also internationally, in order to reflect together how certain elements can be overcome, including legal and financial aspects, but also having the right arrangements in place. I think this can help a lot, because here we see many initiatives that may come bottom up, but I think often these are greatly facilitated if we have arrangements that can be actually planned ahead, and through also a simplified approach, I gather from funding. So these are important inputs that I take from the discussion up to now. Thank you.
Thank you, Leah. Leah, if I could also just come back to something you mentioned right at the end of your presentation. You spoke about values, a list of values. You took us through them quite quickly. Where do you see as the key need to try to get convergence on values where there are other countries, regions of the world where it's perhaps an impediment to further cooperation? Of the values you showed, where do you think the greatest challenge and the current divergence is?
Well, as I mentioned in my presentation, we currently have a number of multilateral discussions with many international partners and many European partners around the table. Actually, the planning is to go through all the values that I listed in the slide. And for some of these, we have already had preliminary or preparatory discussions. So there has been an exercise to identify which values. Many of these values stem from Europe, because we recently had a year ago a pact on research and innovation where we list the values that we share specifically for research and innovation. And the full list of values to be discussed in multilateral fora has been agreed with international partners. And now there is a planning of meetings, multilateral meetings, to see how we share them and how we approach them and exchange information on what we do in practice to make sure that these are mainstreamed in research and innovation. Now, if I can flag some highlights, certainly, as I was saying in my presentation, freedom of scientific research is quite high on the agenda. And also what is called, as part of it, research integrity or knowledge security. There have been different terms that have been used in different discussions. These are quite important, and they are linked to discussions that are linked to foreign interference, for example, and how we can make sure that freedom of scientific research is reinforced and science has the right voice around the table, respecting autonomy of institutions and of the scientific community. And while, so here there are multiple issues. One is that many share these values, but there are also others that do not necessarily reflect these values. So this is one issue. The other issue is, even among those who share the values, how do we monitor their implementation and what we can do to actually promote them further internationally? So this is what is currently being discussed. So methodologies actually to translate values into action as well.
Thank you. Thank you. Any other questions? Again, hands in the air if you wish. Well, we do. Oh, yes, there is a. Please, please. Let me give you my mic. You can shout.
So maybe directly reflecting on what you just said also, Leah. So we are involved currently in a project, so research infrastructures from different fields about remote access, facilitating, well, exchanging experience. It's the e-remote project. And there, of course, I mean, this remote, or improving, facilitating this remote access to research infrastructures has, of course, potential on democratizing access to research infrastructures. It also has also so there's also other obvious, like also the improving resilience in times of what we just experienced, the pandemics and so on. But how would we? I mean, remote access in that sense is in the moment, let's say, on the basis of individual research infrastructure. So how should we integrate then these kinds of ideas on frameworks, the framework conditions that you are formulating with these value-based access conditions? How should those be implemented then on the ground level, on the infrastructure level?
Leah, please.
Yeah. So first of all, I was taking a very broad perspective on the discussions for global approach to cooperation for research and innovation, and all the ongoing multilateral discussions on the table on the basis of the S&T agreements and the different cooperations. So it's really at the highest level, highest political level. When it comes to how this can work in practice when it comes to access, for this, there are, again, different aspects. When it comes to funding from the Union, the conditions of the funding apply. I'm trying to give a very practical reply. We are also working in the context of ICRI and the European Research Area Policy Agenda to actually address the evolving needs for access, and we are going to be producing, through an inclusive process via ICRI, a report on access which will eventually lead to a revised Charter for Access in Europe. So it is relatively early in this process to tell you that this will influence the way you do business today, but certainly all this reflection, I expect that will have some impact in the next couple of years or so. The last point I wanted to mention is about foreign interference. At the EU level, there is a toolkit on foreign interference tips and tricks. And this is also something that could be a source of inspiration in the way that the respective organizations organize this part.
Thank you, Leah. So a practical initial response, but also watch this space for a revised Charter of Access. Thank you. I think we'll change at this point. So let's give this part of the panel a warm hand for their participation. And we move now into well, it's not exactly a half, the last 4/9. And our next speaker is Ed Mitchell. Ed Mitchell is at ESRF, the Central European Synchrotron Radiation Facility, which, among other things, acts as a hub to bring scientists together across Europe, but also plays a catalytic role in some of the international outreaches. So, Ed, please.
Excellent. You took me by surprise then. I didn't realize I was first up. Anyway, is there... I'm going to rattle through some overheads. probably. Okay, so I've been asked to look at these questions here. So we're moving into knowledge exchange hubs. So I'm going to touch on industry and also a little bit more about science for diplomacy in the context of working with research infrastructures. Do I have a didgeridoo? That's fantastic. I work here, which is, it's a very nice place to work. I've been there forever, since 1995. It's the European synchrotron. It's a multinational facility. I'm going to give you 3 examples. One's going to be the ISRAF, one is going to be Sesame, and one is going to be the African Light Source. The ISRAF and Sesame exist. The African Light Source doesn't. Okay, but we'll come back to that. This is the ISRAF. We're funded by 21 countries. You'll see the Russian flag is there. They are a member. At the moment, we've suspended collaboration with Russia for obvious reasons. We're based in Grenoble, down in the mountains. Don't take these as KPIs. Don't take them as, like, I don't know, take them how you want to, right? But this is trying to show you the impact of a multinational facility. Sitting at the center of 21 countries, we go from working with young kids, right? Mostly locally in Grenoble, right? These are primary school kids up to high school. Over the last year, we've interacted with 1,000 of them, inspiring them, showing them what we do at the facility, showing what X-rays are about, showing them what science is about. PhD training. Routinely, we have 50 PhD students at the ISRAF. Okay, it's not a university, it's not that level, but 50 PhD students working with us. I'll come back to that again as well. Over the last 10 years, because we shut down for a massive upgrade in 2019, 2020, so over the last real 10 years, we've been working with a 43,000 strong user community. Right? If you actually do the math, our budget's about 100 million euros a year. If you add that up, the amount of money supporting each researcher is actually very modest. Right? Synchrotrons are probably a good investment amongst the research infrastructures. And we're very open. We've got 21 countries that fund us, but we're open to the world. So again, looking back over those 10 years, those researchers have come from a total of 70 different countries, mostly from the member states, mostly from the big member states, France, UK, Germany, Italy, but from the world over. Industry, we generate about an income of 2.5 million euros per year. We actually have a target now. Our member states, the council, give me, I work in the industry office, give me a target every year, and it's going up by 5% year on year. So we're trying to be entrepreneurial, we go out and try and find new services, we try and find new ways of working with industry to generate that cash income, and that's now knitted into the ISRAF budget. And we have science publications. It's a rubbish metric, because it's not impact, it's just quantity. But nonetheless, it's about 7 per day. Just to focus on PhD projects, this is a Marie Curie co-fund we're running at the moment with 40 PhD students. But it's a little bit special. It's joined between us and the ILL, the neutron source just next to us. Each of those students there has an industrial company who is co-supervising. So here, this is a mix of academia, there's a university, together with a company. You can see the companies. Do I have a pointer thing on this? Yep. Well, I don't know. Anyway, they're there. If you can read that, there's people like AkzoNobel, there's AstraZeneca there, Johnson Matthey, a number of different companies. So each of the kids there have a supervisor at the ISRAF and or the ILL, because we're often combining X-rays and neutrons in working on those industrial-driven topics. We've got 2 whole cohorts going through. They're all now at the ISRAF and the ILL. And these are the next generation leaders of research. Right? They're going to go out with a flavor of what we can do at the facilities, but also what industry can do and how industry works, what drives industry. So they're going out with a sort of a multi-talented approach from what we've been training them in. The students from around the world is Marie Curie, so it's open to the world. And you can see the countries there. And we've got a number of the industrial partners, as I said. Sesame, because I've only got 5 minutes, right? Sesame, there's a special session, I don't know where Jihan is here. There's a specific session tomorrow on Friday where you can go and learn more about Sesame. We had the pleasure of having 2 million euros from Patricia, not necessarily personally, to help build up the user community and the training around Sesame a few years ago. So only 2 million euros. We spent that on 20,000 hours of training for at least 200 people. These are the people you can see in the photographs here. Sesame is amazing. It's really science for diplomacy. It's bringing together a set of countries that would not otherwise be really engaging with each other. Israel is in there, Iran is in there, Palestine is in there, right? When we were over there, I really fell in love with the place. You're sitting around a table and you've got scientists from countries who really not allowed to talk to each other, but at Sesame, they are there. They can. They have the right to do so, if that sort of makes sense, right? And it was an amazing project, and that really was science for diplomacy working very, very well. We had a great time. and it has built enduring bridges, right? It's not just a one-off thing that stopped in 2019, but that work now carries on. Sesame is now part of the LEAPS light sources in Europe, and we're working very closely and continually so with Sesame. This is a map of light sources. It's not all the light sources around the world, because there'll be more than that on there, right? But you can see where the clusters are. Yesterday, someone was mentioning that research infrastructures are not distributed evenly across the world. They're not, right? You can see there, it's global north, with the clusters in the usual places. And there's one very obvious hole, right? There's one in Latin America. There's a few bits and pieces across in Australia and stuff like that, but there's nothing in Africa. Absolutely nothing there in terms of an advanced light source. So there is a group of people, there's a number of groups of people working in Africa. I'm proud to be associated with some of this. You can go and look at it there, africanlightsource.org. They have had some sessions at ICRI earlier this week. They've been virtual. There is the 4th African Light Source Conference coming up on the 14th to 18th of November. It'll be in virtual mode. We held one in-person in Grenoble, one other in-person in Ghana, and we hope there'll be another in-person one coming up. But this is working in a bottom-up way to try and put in place a light source in Africa, by Africa, and for Africa. And this is certainly where the global community of research facilities, especially the light source you can get involved and help. Not through charity, because Africa is quite rightly a proud continent. So it's not charity, it's collaboration and helping and support. So we'd like to see more training, capacity building, mobility. There was in the African Light Source meetings earlier this week, they were crying out for support in training, accelerator physics, management of research infrastructures, user-based stuff, building up that capacity. And they're very excited to try and move forward with a light source, maybe by 2035 to be seen. Yesterday, we published a comment piece in Nature Physics Reviews. So go take a look if you want to. It's there, it's open source, so you can go and find it. Looking to the future, I only wanted to pull out two things here. They're a little bit similar to what you already heard from Miriam, I think. There's almost a challenge around light sources, because by their very nature, they are a success. Right? We heard from Andrew this morning that we've got increasingly broad user communities. They don't care about the details anymore. That's okay. It's not a bunch of physicists running stuff in the 1990s. This is a very broad and diverse user community, and they don't care about the details. That makes us a challenge, because we have to add value in services and more than just having users coming to us. So everybody wants a light source all around the world, and that's good. There's an SME challenge. We're always told SMEs are the drivers of innovation, but they have no cash, they have no resources, and they certainly don't internally know how to use a light source. We've been very lucky in Calypso Plus, Leaps Innovation, and Remade now, which you heard about, to have some money from Europe to help subsidize SME access. They can keep the results confidential. So one example through Calypso Plus, we had Takis Biotech, small Italian company, using us for protein crystallography and looking at some COVID-related structural biology. Another one where I can't name the company, but from Cyprus, they've used us for some work on composites. So looking at how using tomography to look at the composite structure. And now that's leading them into a proposal for Horizon Europe funding, using some of the results they gained from us. What do we need? Andrew said it this morning, renewed business models. I feel, take my ISRF hat off temporarily, I feel we're still working in the 1990s. We need to add value to go beyond the normal business, not just X-rays, not just neutrons, not just electrons, but add value so that we can provide the users with real services. We need an ongoing SME subsidy. The work we're doing in Calypso Plus, Leaps Innovation, and Remade is just a start. And it's just for light sources till now. Now some of the analytical facilities, we need to keep that going. And the other thing is targeted funding. It's always the same. Mobility, support for training, support for visibility, for user communities, wherever and whomever they are, across the world. Open Sesame was one example. It would be great to see more of that kind of work going on. And with that, I would lasted much more than 5 minutes, right?
That's fine. I might have, oh no, it's on again. Thanks, Ed. So we move on now to Hank Löscher. Hank. Great. So Hank, National Ecological Observatory Network, involved in developing synergies across environmental research infrastructures globally. So please.
Thank you very much. I'd like to also thank the organizers for this opportunity and everybody that's staying late here at this session and those around the world. I was asked to speak about a new initiative called the Global Ecosystem Research infrastructure. And some of you that were here yesterday may have heard some of the earlier talks in the plenary session that introduced that topic. But first, to give an idea of what an ecological observatory would be, or an ecosystem research infrastructure, I'm going to use NEON as a quick example. Also in today's meeting, we also talked about, earlier today at the 7:30 meeting, we talked about national priorities and how we actually gin up research infrastructures. And so, NEON was designed from about an 8-year process from the National Academy of Sciences in the US, as well as a strong effort from bottom up from researchers. And we've got community-driven grand challenge questions that then led to what we actually have to be able to measure at any particular site. So it's beyond just fluxes and flux towers. It includes aquatic biodiversity, ecological processes and their drivers. And then we also use remote sensed aircraft to take that information and scale that up to a larger sphere of inference so that we can map that to different types of satellite data. And it's very large, it's complex. We've got mobile platforms, we have biorepositories, large end-to-end streaming data, etc. And operations are very complex. Let's see if we go the other direction. Big button. And then we map those across the continent so we can take local information and scale up the drivers and the processes, ecological processes, to the landscape, to the region, and to the whole continent. We've got 81 field sites, 181 data products, planned for 30 years of data. We're up and operational and have been for quite some time. So with that said, that a large-scale ecological network at a continental scale, we recognize that that's a very unique type of data. And there's very few of those around the world. And so one of the places where we recognize that value add is in combining that and to dovetailing and to have synergies with other types of ecological data, from the principle-based investigators, other long-term networks, coordinated experiments, and the like. And each of those type of organizations that collect that type of data, it's really unique. It brings a different facet of the overall data. And that proposition of doing that goes beyond that of the original design of an ecological research infrastructure. And so that leverages our federal investments and the agency investments and dovetails with other agencies as well, and provides then a framework to be able to then say, this is exactly what we actually can offer and how do we actually work with these other entities, and provides us the opportunity to work across platforms. So that said, the global ecosystem research infrastructure is an early initiative. We've been working on this for a few years now that bring together several different ecosystem research infrastructures globally. They're listed here: ICOS, CERN, SEAN from South Africa, NEON, ILTER here in Europe, and TERN in Australia. Totally, we've got over 1,600 sites. And the opportunities that this then brings is that there's a really large scientific imperative, not only at the agency level and at the country level, but really strong interest from the research community. So what does that actually mean? So being able to bring together the lessons learned, how do we actually operate those infrastructures together? What are those safety protocols? What are those codes of conduct? How do we harmonize the data to be able to now ask questions not only at the continental scale, but across continental scales? and train the next generation of researchers to tackle those unknown ecological problems that we know that are going to come up in the future. The challenges that we've faced are that each one of those infrastructures have different responsibilities and roles to their user community and to their sponsors that we have to really better understand. And part of that, there's some cultural sensitivity to it as well, or at least how those programs are run in their own cultural settings. And being able to fund this across geopolitical boundaries, it's unlikely for any one particular government to provide resources to another. So we have to seek those sources within the programs themselves or within those countries themselves. Solutions collectively, what we've done is we've really worked on identifying what our identity is, what we actually are, what we have to offer in a very culturally appropriate setting. And we've done that through a variety of meetings that include researchers from the bottom up, agency members, etc. We've established a value proposition and mission statement. We've developed a roadmap of how we're going to tackle some of those activities that I had mentioned earlier. We have a strong governance structure, but we wanted to make sure that it was appropriate. So one that can span the geopolitical boundaries, not be onerous, but be strong enough to bound all the interests together. And that took time to be able to develop that. We managed that through a memorandum of understanding, and currently much of the development activities are accomplished by in-kind resources. Right now, going sort of full circle to transnational access, we've got opportunities for visiting scientists on how do we actually glue our resources together. We have different pathways for other networks to participate. Now that we have a value proposition, we can actually say this is who we are, so that others can actually see how they can contribute to this process. Broadening participation, I'm going to actually point out we're very conscious of diversity, equity, inclusion, and accessibility. I'm surprised I don't hear more of that here. I've only heard it a little bit here, actually, in the last previous talks. And then a large effort then into harmonizing our data. We already have all of our data in registries. To be part of GERI, we manage and assure that all data are open, fair, compliant, and meet the Creative Commons international licenses. And we also want to do not only that we want to be able to demonstrate the utility of being able to harmonize our data and why we would come together around specific scientific questions. And the one that we're working on right now is ecological drought, which differs from meteorological drought, how the availability or the lack of availability of water affects ecological processes and societal benefits. And being able to glue that together in a new type of a model that then all the research infrastructures themselves hold onto their data. We pull it all together and federate it and wrap that into a web service that can be placed in any type of data portal, either the research infrastructures or elsewhere, so that researchers can actually then access that and not have to be able to search that based on a particular research question. One of the reasons why we chose ecological drought, and I just wanted to say this as sort of as an example, is that the genesis, development, and transport of drought across the horizon and its relative effects on the ecology, food security, migration differ from continent to continent to continent. And being able to pull together these data in the context of a global, in the context of GERI, actually then we can compare and contrast and learn from that in a very consistent way. That's it. So thank you very much. One more minute. I'd like to thank all of our sponsors that got us this far.
And great timing. Thank you very much. So now we're going to move on to Claudia Amara from Instruct, which of course provides a platform of different facilities for the life sciences. But I think you're going to talk to us more today about Revis, which is engaged in outreach beyond Europe in this area. Thank you, Claudia.
Thank you. Yeah, thank you to the organizers for the invitation to come to tell you. The brief I have for today is to tell you not as much as what INSTRA has been doing in structural biology, that is our main objective, but what we have been doing about visibility of research infrastructures and going global, trying to reach international collaborations. Then INSTRA-CERIC is the European Research Infrastructure Consortium for Structural Biology Research. And we are an ERIC. I'm sure during these 2 days you have heard from more than one. We are a European organization. We have 14 members, 13 countries plus EMBL. And we provide a single point of access to technology and expertise for structural biology research, but we are open to more than the structural biologists. And our model is that those countries pay a fee per year, and that allows older scientists to access our infrastructure all over Europe. And this is what our infrastructure looks like. We all have always taken an integrated approach to structural biology. We go from sample preparation, biomolecular analysis, to structural analysis. And one scientist can, through only one application, do their protein in Strasbourg, then do their biomolecular analysis in Amsterdam, and then do their NMR in Italy. And that's not a random selection, it's one I was looking at not that long ago. And then in the last 10 years, we have got, I believe, pretty good at doing this, building this system, getting a proposal system going, reviewing, setting up visits, setting up, helping scientists go from one place to another, and then reporting to our many funders. We got that working. But then we face a big challenge that is not just us, it's all research infrastructures, that is visibility. People in the movie says, if you build it, they will come, but they have to know it's there. And I cannot tell you how many times I've been to meetings and I ask people, do you know about Instruct? No. But not only Instruct. Have you heard of Eurobioimaging or EU Open Screen or InfraFrontier, any of our infrastructures? And the answer almost always is no. They don't know that it's there. And if they don't know it's there, they're not going to use it. Then visibility is a great challenge for all our infrastructures. And then there is the opportunity to go outside of Europe and offer our infrastructure globally. Then this challenge and this opportunity were the basis of our involvement in 2 Horizon Europe projects that I want to tell you all today about. One is RAVIS, and the other is EU-LAC ResInfra. One has to do with this challenge of visibility, and the other with the opportunity of going global. Then within, I don't have time today, but I'm here if you want to ask me about. We did a lot of work in providing tools for communication for research infrastructures, because all of us work very hard to create our communication tools, and if there is a new infrastructure getting set up, we don't want them to go through the same painful process. Then if you go to the RIB's website, you will find a communication toolkit that will allow you to jump some of those barriers without having to go through the same process. But of the many things that RIB did, and I invite you to go to the website, I want to tell you specifically about 3 symposia we organized in these 3 areas to increase the visibility of our European research infrastructures abroad. And one main thing about this symposia, how we organize it, is that we didn't do it alone. We first got in touch with colleagues in the 3 regions, and we organized it together. And I think that was the basis of the success of this symposia, because we were not just us going to tell them anything, we were organizing something together. And this symposium was supposed to be in person, but COVID happened, and they ended up being virtual. And the silver lining is that we ended up being able to integrate a lot more people because of being virtual. As you can see, they were very well attended, and when I mean that we got in touch with people in this region, it was not only researchers. We got involved with policymakers, with ministries, with all the stakeholders to make sure that they got together. And in some of these meetings, the researchers told us that this was the first time they got the chance to talk with their own policymakers. That in a way, RIVs allow them to have a conversation with people that are in their same country, but they have never got the chance to talk to them. Then that was really inspirational. In preparation for those symposia, we prepared 3 white papers looking into recommendations for research infrastructure collaboration. Again, I don't have time to get into these white papers, but they are available in the RIV's website, and they are also available in Zenodo. Have a look and give us your feedback, because we want to improve them. We want to make them better. As I said, INSTRA has been trying to interact with the world from the beginning, and this describes some of the interactions we have done through the years, and we have used as an instrument the signature of MOUs. Again, in our case, we have to write those MOUs from zero. We have to set up and write it. And what the RIV's project did was collecting our MOUs and the MOUs, the other infrastructures involved in the project there, was make a template. Then when a new infrastructure have to go through this, they can go to the RIV's website and find it and use it without, may decide it's not good enough, but at least they have a starting point. They don't start from a white page. That is how we started. Then we have signed MOUs with all these regions. And this international collaboration was very much enhanced for our collaboration with EU-LAC ResInfra. Funding from this Horizon 2020 project allow us to open international calls that have scientists going from Latin America and using our INSTRAC facilities in Europe. Those were normal access visits, short 1 to 2 weeks visit, or remote access, depending on the facility, but we also did more long-term staff exchanges, 3 to 9 months, 12-month long-term visits. And this is just a placeholder. Have a look at this other project, Can Serve an Easy Door, because this is part of the new way how access is funded, and it's something we need to discuss, and we need to make it work for all the communities. Then just put it there, but we should talk if we meet in the corridors about these projects. And INEX is similar, but for translation structure biology. Then with this, as I said, this is just mentioning many, many initiatives where we have going. The other initiative, thank you, Michael, for mentioning e-remote, that is looking into remote access, that within our international call in particular, our ResInfra international call, remote access showed to be very important, and through the project, we are trying to make it better. And I want to say that without the support of the Commission, none of these cross-infrastructure opportunities could have happened. Then thank you again for your support, and thank you all for your attention.
Claudia, thank you very much. Very nice, diverse set of examples. So the last speaker in this session is Werner Kutsch, who's going to talk about ICOS, the Integrated Carbon Observation System, which actually has already been name-checked in Hank's talk as part of a global initiative, in this case to look at greenhouse gas across the world, through measurements on land, sea, and air. Werner, please.
Hello, and I'm not talking so much about ICOS itself. I'm talking about our global cooperation. But you gave me some hard time in preparation of this talk, because I got stuck at the word complexity. And then I was thinking, what is complexity? How can we measure complexity? Is complexity constant across scale, or is complexity, are there peaks of complexity? We can make a scientific conference on complexity through all the dimensions. Or is complexity a KPI in the next evaluation of a research infrastructure? So I even started to discuss this yesterday evening with some colleagues over some beers, and after some beers we really thought, okay, this is going to nothing. So it's complex with complexity. But then this morning I woke up and I thought we have the ERIC Forum, and the ERIC Forum is about exchange of experience among research infrastructures. And you have to learn from your colleagues, and your colleagues in particle physics and astronomy, they always cite a Nobel Prize. And that's what I'm doing here as well. The Nobel Prize in Physics 2021 is going to these three, or was going to these three gentlemen for groundbreaking contributions to our understanding of complex physical systems. They found the hidden patterns in the climate and other complex phenomena. So yes, the Earth system is complex. That's the focus of ICOS and other research infrastructures, and they are showing in the scientific background paper even the observations of carbon dioxide in the atmosphere. So we can tick the box. Our science is complex. But I want to draw your attention to two things. We have two research infrastructures in Europe, ICOS that's doing the observations, and EasyNet that is doing the modeling. And this was the model, this Nobel Prize about. The Nobel Prize was about finding the imprint of humans in the atmosphere, in global change, through models, but you only can justify this when the models fit the observations. You told the same story. There is a quote from the Nobel Prize text, and I think that's also something that is important about the sustainability of research infrastructures, because they are making a difference between experiments and observations. And now think about running a synchrotron. You are doing an experiment, somebody pulls the plug. That's bad. But you can come back and start the synchrotron again, and can you repeat your experiment? Now imagine you are observing whatever the atmospheric concentration of a greenhouse gas. Somebody pulls the plug. That's also bad. You can restart, of course, your instrumentation, but you cannot go back in time. You can't go back in time. A measurement that has not been done today, an observation can't be repeated tomorrow, because it's an observation of a specific situation in this complex system. And that's why we need the sustainability of research infrastructure, in particular when they are doing observations, because we can't fill the gaps that we have in our observations. So now coming to international cooperation, I would like to distinguish in three dimensions the international cooperation. One is the vertical cooperation with international organizations and programs. The other one is the horizontal cooperation with similar infrastructures in other continents. But then there's also the transdisciplinary cooperation. So the first example, the vertical cooperation, this is the so-called value chain or value pyramid that is related to ICOS data. So I said we are doing observations. We are doing observations in the oceans, in the atmosphere, and in the ecosystem on greenhouse gases and greenhouse gas fluxes. And this is our main access, ICOS data. The data are completely free. People are using this in models. People are using this for scientific analysis. So the next level in this value chain is the scientific analysis of this data. And finally, or in the next value, you have assessment. You have organizations like the Global Carbon Project, like the IPCC, like the WMO. They are digesting the digested data. So they are taking the scientific results, they assess it, and they bring it to the highest level. And this is, in our case, the UNFCCC, the Paris Agreement, and then we have informed societies and we have informed politics. But there is also, for example, the Convention on Biological Diversity, and that's where we cannot say very much as ICOS. So we need a broader landscape of observations. We need more research infrastructure in the environmental domain, and that's the so-called ENVI community. You see here the whole zoo of our environmental research infrastructures in Europe. And we are having this transdisciplinary, cross-disciplinary cooperation. For example, we are trying to bring all our data together in the ENVI Hub in the European Open Science Cloud, where we really want to build data access for transdisciplinary studies in the environmental domain. And finally, and I don't have to talk a lot about this because Hank did this. This is the horizontal cooperation between infrastructures in different places. And the circle is closing in a way in the fourth bullet point. We are discussing to work together in this UN organization. So we are working together, for example, towards a global greenhouse gas observation system that is currently introduced by the WMO. So I think these are the 3 dimensions, and I hope I could show you that we are covering all the 3 dimensions. And this is already my final slide. It's complex with complexity, but it's simple to cooperate. You just have to do it. Thank you.
Thank you, Werner, for finishing off in such an elegant and thought-provoking style. I note in passing the interconnectedness of science. Giorgio Parisi starting his career in glassy magnets and now, branching out into complex world systems. So thank you. And I'm not going to let this run over. We have 15 minutes to conclude with a few questions. So Werner, you can grab yourself a seat. Could the other 3 speakers, please, from that last bit of the session come to the front? Now, you've actually answered, I think, between you already, and I'm not going to ask you to answer it again, the question I had for you, which is, how do you raise the visibility of, I couldn't dare to ask you to go through it again, Claudia, because that was your presentation, really. So I'm not going to ask you that. I actually have, and having asked people to send in questions, I have a couple of questions from the audience. I'm going to ask at least one of them. And the first question is, how can we strengthen and fund user access to RIs, in particular for those nations that don't host RIs? And maybe Claudia.
Actually, we just had a session before this one, and there was a really outstanding presentation by Lionel Malacrida from the Institute Pasteur in Montevideo. And he had this drawing of a mountain with increasing peaks, because he's saying, people say open access, but an infrastructure can open the door. That doesn't mean that the researchers in every country will be able to use it, because they don't have the expertise to produce the sample necessary for this, or many other things. Then they are in Latin America. Part of the work of the ResInfra project was to discuss setting up regional hubs that could be an intermediate step between the researcher, in this case in Latin America, and the infrastructure, not only in Europe, but their own infrastructure in Brazil. Because the Brazilian colleagues tell us they have similar issues. Then these regional hubs can really serve an intermediate point between the two. And again, thank you to all of this European support. We have been together with Eurobioimaging in many projects, and this is another opportunity when we are, Instruct and Eurobioimaging, are thinking and working together to advance on these regional hubs, to bring together the researchers. And then when we open the door, we open them for real.
Thank you. Ed, you sort of suggested that you might want to add to that.
I might do. I think for the larger scale facilities, it's important to be aware that we have shareholdings, and they're very agile and flexible shareholdings. So within the ISRAF membership, not everybody is equal. So the French and German have the largest shareholding, but we have very more sort of modest shareholdings or associate membership from other countries who can join. And the joining process can be actually quite rapid. We're in discussions at the moment with Greece. As a bottom-up process with their researchers, they're interested to try and join the ISRAF. And often when we've got countries like this trying to join, we can do specific outreach and training activities to help culture the user community within the country. And they can join at very modest levels, right? Sort of even fractions of a percentage that then can grow with time as the use and the interest changes.
Thank you. Hank?
Yeah, I think I'd answer it slightly different, is that maybe there's a bias in the room too, because Europe has a transnational access program, and even the US doesn't have that. So part of it is also the awareness that there are partners out there that want to be able to work, and there's capabilities and resources available outside of our country domain. And unless you're aware of it, you don't put it into your proposal. And the only way that US funders or other countries in their award structure, their granting structure for their proposals, you'd only be able to work internationally if you were aware of it and you were able to put that into your proposal and get that approved. So maybe I've always loved the model of transnational access, and I've been advocating that personally at NSF for years, that they need to have a program like that. But and it's unique. I also want to recognize that it's unique for Europe, and I think that's that warrants recognition and praise as well.
And just a bit, and I'll let you go in a minute. TNA, who should pay for it?
Who should pay for?
Transnational access.
I think I'm going to dodge that. That might be above my pay grade at the moment.
Okay, one for the bar.
Now, I would like to bring the viewpoint of distributed research infrastructures in here. So you can download from all over the world our data, and you can download the yesterday's data. So we are very, very near real time. But it's a European network, and there is not. There are, I think, 2 or 3 atmospheric observational towers in Africa. So we had the gap of Africa in other things. So you could see the map. The stations are not evenly distributed over the world, and that's, I think, it's not excess, but we should help to fill the gaps in these countries, in these regions, because climate change is affecting Africa, South Africa, India in the same way as Europe, but we are not really having the high quality information with the dense distributed networks in other regions, and that's where we have to work on.
Thank you. So again, another question for you, and it's actually something you prompted, Hank. You said we haven't actually mentioned diversity, equity issues really very much in this or the other sessions. So question to each of you, what do you think RIs can do to promote equity? Who wants to go first?
That's a good one.
Go on, Claudia.
I think when we were organizing those symposia, it was very clear. Each symposium we did, we got better at doing it together and do it in an equal footing and generating the work together. And I think that was very valuable. We have, and I'm going to plug this one, we have done a report on structural biology landscape analysis for infrastructure in Latin America. And we set up that working group, again with funding from ResInfra, but the chair of that working group was from Brazil. And I think you have, we were talking today at lunchtime about women in Latin America, and being vigilant is important. Sometimes saying that panel is only men, I'm not going in. Being vigilant, and sometimes I don't think men do it on purpose, it's just they are not looking. Then in all matters, I think being vigilant, being aware is at least a first step. And because research infrastructures in Europe we are all distributed, we have this richness of cultural and diversity, I think we can help in that point.
Thank you, Claudia. Anyone else wish to jump in? Gentlemen.
I think the UN system is important, at least in our case. So if you go to the Conference of Parties of UNFCCC or to the WMO Congress, all the countries, all the 196 countries, member countries are there. And I think that's a very important forum to cooperate. And I think, yeah, I think we need directly to cooperate in a really respectful way. And that's also important.
Thank you. Hank?
Yeah, I've got a couple of comments around that. One, I saw a slide earlier about gender equality as one of the metrics, and I want to make a distinction between equality and equity. And equality is like having everybody at the table. Equity is making sure that they're part of the vertically integrated, the decision-making process, and all have the equal type of opportunities. And I know that we all do that, but we do that sort of serendipitously, or that's just the way that we behave ourselves. But there's a difference there, and that we should be very aware of it. And it becomes particularly salient or to light. And I'll use an example of environmental monitoring in the Arctic, where the Arctic has people, and those people, many of them are part of a different type of sovereign nation. And equity and inclusion and cultural sensitivity means something very different than are normally in our common workplace. And to be able to work, say, on data sovereignty issues or access, even just physical access, being able to co-develop knowledge, you have to bring in all of those principles of equity and inclusion. Two other quick points. White House now in the Arctic has guidelines on how to do that. And more organizations are incorporating codes of conduct, and that might be another place here where infrastructures can actually establish and harmonize codes of conduct to recognize that more explicitly. And lastly, in NSF world, in the RFPs and the request for proposals, it's mandated now a lot. So we have to be extremely conscious and be innovative in being able to demonstrate how we're going to do that.
Thank you, Hank. And Ed?
Just fast. So Africa can teach us a lot. In Africa, there's a concept called Ubuntu, which roughly translates as I am because we are. We could do with a lot more of that in the world at the moment. This is embedded into the African Light Source project from the outset. And for example, the conceptual design report that's being built at the moment for the African Light Source is being built in that way, with the process being utterly open to anybody who wishes to contribute. You can all contribute if you want to. The process is open at the moment. It's being done through a website, and people can contribute letters, expressions of interest, topics, things that they would like to see in the CDR. So it's very African-based, but there's also been a lot of contributions from around the world. And that's all based on having Ubuntu at the foundation of what the African Light Source is trying to do.
Thank you.
Great example.
I promised I wouldn't overrun. We've only got a few more minutes, but does anyone else have any last questions or perhaps comments? And that includes the panel, if any of the panel would like to make any final points that they believe ought to be said. Hands up if you wish to speak. If not, then should we draw this session to a close? Let's thank these four, but let's thank all 9 panelists for a really lively, interesting session. Thank you very much, everybody.